Understanding the unit circle. The unit circle has a radius of 1, and we can use the unit circle to find angles and points on a coordinate system. For any general angle, let theta be an angle with xy point on the terminal side of theta, and the radius r not equal to 0. And r we're going to call equal to the square root of x squared plus y squared, and that is not equal to 0. So this is going back to when we were studying conic sections and circles. It's a similar idea. Okay, so if we were given an xy point on a coordinate system and we wanted to apply that to the unit circle, then what we would say is cosine of theta is equal to x, sine of theta is equal to y, and tangent of theta is equal to sine over cosine, so that would be y over x. And then we can find the opposites of all of these, which would be secant of theta, so that's the reciprocal of cosine, which would be 1 over x. Cosecant of theta, which is the reciprocal of sine, so that's 1 over y. And cotangent of theta, which is the reciprocal of tangent, so it would be x over y. So if we do that, then we can find all 6 trigonometric functions given a point on a unit circle. So let's do an example here. We have 3/5, 4/5. So we know that our x is cosine and our y is sine. So I can go ahead and start by writing cosine of theta equals 3/5. Sine of theta equals 4/5. And then I need to find tangent of theta, secant of theta, cosecant of theta, and cotangent of theta. Okay, now it will help me if I draw it out. So if I'm looking at this, I know that my x is cosine, so it's going to be adjacent over hypotenuse. So my x is going to come out like this, and that's going to be 3, and my hypotenuse is 5. And then my sine is 4 over 5, so that's going to be 4. That's opposite over hypotenuse. So right there is my theta. So now that's the triangle I'm going to be looking at, and I'm envisioning this point right here to be on the unit circle. So that's why my theta is where it is. Okay, so now the next thing I want to do is find the rest of them. So if I find tangent, tangent is opposite over adjacent, so that would be 4 over 3. My secant is the reciprocal of cosine, so I'm just going to flip that, and it's going to be 5 over 3. Cosecant is 5 over 4. And finally, cotangent is 3 over 4. All you have to do is flip them. All right, so that would be finding the 6 trigonometric functions. For this next one, we have the point 11 over 61 and negative 60 over 61. So I'm going to start with my cosine of theta is going to equal 11 over 61. Sine of theta is going to equal negative 60 over 61. And then I want to make sure I understand what this looks like. So I'm going to graph it out. I know that my cosine is my x, so it's going to go over 11. And then my hypotenuse is going to be 61. So this is 61, and this is 11. And it's got to go positive because that was positive. And then I drew my hypotenuse like that because my sine is negative, so I'm going down. So that is my point on my unit circle. And now I can find this is 60. Actually, it's negative 60. And here's my theta. All right, so now if I find my tangent of theta, that is going to be equal to the sine or opposite over adjacent, so negative 60 over 11. And secant of theta is equal to 61 over 11. Cosecant of theta is equal to negative 61 over 60. And finally, cotangent of theta is equal to 11 over negative 60. So there's your 6 trigonometric functions. The values of the trigonometric functions of angles greater than 90 degrees or less than 0 degrees can always be determined from their reference angles. And this will help us when we're understanding our unit circle. We can generalize things as anything between 0 and 90 degrees, no matter what. So we need to be able to identify what our reference angles are. If we have an angle right here, and that is theta, then we are already at our reference angle. That's just going to be the same. The reason that is because that angle is less than 90 degrees and more than 0 degrees. All right, the next one, if we have an angle right there, and this is the angle, theta, then we want, that is clearly more than 90 degrees. So I'm going to generalize it with a theta prime, which is going to be my reference angle. To find that reference angle, I'm going to take pi, and I'm going to subtract off whatever my theta is, and that's going to give me my theta prime. All right, the next one, if I have a reference angle that goes down like this, then this being my theta, I want my reference angle to be in relation to my x-axis, so it's going to be right here. So if I want to solve that, I'm going to take my theta, and I'm going to subtract off pi, because I know from here all the way over to here is pi, and that is going to leave me with my theta prime. And the last one is if we have it in that last quadrant right here. And this is my theta. Then my theta prime is going to be right there, because that is with the x-axis and it's less than 90 degrees. To solve for theta prime on this one, we're going to take 2 pi, because that's the distance all the way around, and then we're going to subtract off my theta, and that's going to leave me with my theta prime. So you'll have to get comfortable enough to understand what the reference angle is. The reference angle must be less than 90 degrees and more than 0 degrees. All right, so let's do some examples. If we have 300 degrees, so the first thing I'm going to do is draw 300 degrees. So I know that all the way around the circle is 360. So 300 is going to be somewhere down here. So that is 300 degrees. But I want to find my reference angle. So my reference angle is going to be less than 90, so it's going to be this one right here, theta prime. So I want to find theta prime. So if I want to, I could convert it to radians and then use the 2 pi, or I can just use 360 degrees. So if I take 360 degrees minus 300 degrees, I'm left with 60 degrees. So that means that theta prime is equal to 60 degrees. And then you can convert that to radians, just depends on what you're looking for. And the next one, if we have our angle at negative 7 pi over 6, well, like I said, halfway around, if it's negative, we're going to be going clockwise. So I'm going clockwise halfway around, that's pi. So it's a little more than pi because it's 7 pi over 6. So I'm going to be coming all the way around to about there, and that's where my angle is going to be. So that is negative 7 pi over 6. And I want to find my theta prime, which is going to be less than 90, so that's my theta prime. So to find that one, I'm going to take 7 pi over 6 and subtract off pi. And I'm going to go ahead and make that a common denominator. So that would be 6 pi over 6. 7 minus 6 is equal to 1, or pi, over 6. So that means that my theta prime is going to be pi over 6. And that's your final answer. Those are your notes over understanding the unit circle and reference angles. Go through some practice problems, and then you should be ready for your quiz over the material.